Okay, here we have 2-2, the triangle inequality theorem. Now this says any two sides of a triangle must be greater, and guys, I want you to write this down, greater than the third. So everybody should be writing down the triangle inequality theorem that any two sides of a triangle must be greater than the third. Now what do we mean by that? Well, let's go ahead and take a look here. I'm going to switch up my colors just so you can kind of see at example 1. And what if I said 2 plus 6 was greater than 5? And the question is that a true statement? Well, I know that 2 plus 6 is going to be 8, and 8 is in fact greater than 5. So yeah, that checks out. Okay, well what about 2 plus 5, is that greater than 6? So I'm just kind of switching the order of my sides here to make sure this statement is still true. We know that 2 plus 5 is 7, which is in fact greater than 6. That's true. Well, let's try one more. This one might seem a little silly to y'all, but is 5 plus 6 greater than 2? And I would hope that most of y'all would say yeah. We know that 5 plus 6 is 11, which is in fact greater than 2. So since no matter how you spin this triangle, any two sides add up to be greater than the third, this is in fact a triangle that can exist in real life. Now what about example 2? Let me use a different color for example 2. What about 3 plus 5, is that greater than 9? 3 plus 5, is that greater than 9? And the answer is in fact no, because 3 plus 5 is 8. Is 8 greater than 9? No. So this is in fact not a triangle that exists. Alright, I'll just write it like that. It's not a triangle that exists. Okay, pause the video here and let's go on to our third example, which you have to watch because this will be the most important of them all. Okay, here we have our third example, which inequalities describe the possible values of x. Okay, and here you know that wording is a little bit strange, but basically I'm trying to figure out like how can I create an inequality that represents the possible values of x? Well, notice we have a 3 and we have a 7, and x could either be too small and then it just would not work, or x could actually wind up being too large. And there's kind of a sweet spot where we want to find x that could actually make a triangle in real life. So how are we going to find out when x is too small? Well, we do this by subtracting. We'll say, whoa, I don't know what that is. We'll say 7 minus 3 is less than x. Okay, so this is when it's too small. So this value would be less than x. And then x is less than the value that's too large. And we would do this by adding. So what's 7 minus 3? Well, 7 minus 3 is 4. We'd say 4 is less than x is less than, and 7 plus 3 is 10. And this literally describes all the possible values of x. Okay? So, for instance, if we were to say that x is equal to 5, or 6, or 7.25, or 9.99, all of these would be examples of x values that would actually work. What about some things that would not work? So this little symbol right here means x does not equal. Well, x couldn't equal 2, that's too small. X couldn't equal 100, that's too large, it's bigger than 10. And you know what x also couldn't equal? X couldn't equal 4, and x couldn't equal 10. Because 4 is not less than 4, and 10 is not greater than 10. So those values on the boundary, those are not parts of x either. Okay, let's try letter B. Let's try letter B. Okay, so from here, we know that what we're going to do is we're going to add and subtract. So I'll always use my bigger number first for the subtraction, and we'll say 20 minus 5 has to be less than x, which has to be less than 20 plus 5. Okay, well we know 20 minus 5 is going to be 15, is less than x, which is going to be less than 20 plus 5, which is 25. And so here is our range of every single x value that we could possibly have. Okay, so what are some x values that would actually work here? Well, x could be 16, x could be 15.01 because that's bigger than 15, x could be 19, and x could be 24.5. It doesn't really matter. All of those values would work. And what are some values that x could not be? Well, let's see. X couldn't be 14 because that's less than 15. It's outside of our range. X couldn't be 15 because we're saying that 15 is less than x. You can't say 15 is less than 15. That doesn't make sense. Okay? And of course, anything bigger than 25 is out as well. So 26. Any number greater than 25 just won't work. Alright guys, I got one final example. Please stay tuned and pause this if you need to finish taking notes. Okay, and example 4 says this: which of the following is a triangle? And so let's see, all of these are going to represent sides of a triangle. Let's see what we see. So here we have 3, and let's say it like this: 3 plus 5 is greater than 8. Is that true or false? Let's see, what is 3 plus 5? That is 8. And is 8 greater than 8? Is that a statement that's true? Well, no. If something can't be greater than itself, alright, remember these are inequalities. These are things that are unequal. So we're not looking for things that are equal. Okay, let's look at the letter B. Now letter B says this. You know what, I'll use a different color for letter B. Letter B says 4 plus 11 is greater than 2. Is that a true statement? Let's see, 4 plus 11 is 15, and is 15 greater than 2? Yeah, that's definitely a true statement. But wait a second, what if we try a different combination here? What if I say, is 4 plus 2 greater than 11? Well, 4 plus 2 is 6, and is 6 greater than 11? No, that's not true. So we know that that's not a triangle. We know that's not a triangle. So it's looking like our answer is going to be C. But let's go ahead and try this out. Here we have 15 plus 12. Is that greater than 5? Let's see. 15 plus 12. Is that greater than 5? Well, 15 plus 12 is going to be 27. And that's definitely greater than 5. So that checks out. Let's try a different combination. What about 12 plus 5? Is that greater than 15? 12 plus 5 is 17. 17 is greater than 15. Yeah, that checks out. And lastly, what are we missing here? Oh yes, let's do 5 plus 15. Is that greater than 12? Well, 5 plus 15 is 17. Oh, wait. 5 plus 15 is 20. Sorry, y'all can tell I haven't had my coffee this morning. And we know that 20 is greater than 12. And so check it out. Boom, done. Our answer is C. So remember, the triangle inequality states any two sides must add up to be greater than the third. I'll see you guys in our next video.